This is a video on earth electricity, or telluric currents, these days called geomagnetic induced currents, or GICs. The example given to demonstrate how the Earth's geodynamo works is an alternative design for a dynamo originally invented by Michael Faraday. Michael Faraday made our regular dynamos that we use today. This is the design for a conventional one, shown here. The conventional dynamo uses relative motion between the stator and the rotor to create electrical current. The other dynamo that Faraday created, which resembles the Earth and how it functions, is called the homopolar dynamo. Faraday's homopolar dynamo does not have relative motion between the stator and the conductor. The stator and rotor in a homopolar co-rotate, meaning instead of, in this conventional design, the magnet stays stationary and the wires revolve, both the conductor, here as displayed as a copper disc, and the magnet rotate together without relative motion between them. This is the homopolar design. Shown here is a homopolar dynamo next to a depiction of the Earth and its magnetic field. Yellow arrows are shown to indicate the rotation direction of the Earth. As the Earth rotates with its magnetic field, it's basically an incredibly large version of the Michael Faraday homopolar dynamo. In the case of the Earth, the oceans take the place of the conductive copper disk, and the Earth's magnetic field takes the place of the magnet in the homopolar dynamo. The effect is pretty much the same. The Earth will output electrical energy just as a homopolar dynamo of Faraday does. Earth does this within the frequency range of 7 to 30 Hertz usually. This is the extremely low frequency ELF range. This range is also used by the U.S. military for naval submarine communication as it penetrates salt water. Here we see two different designs for receptors or antennas for geomagnetic energy. One natural and one man-made. A river that connects to the ocean becomes basically an electrical energy conduit for these telluric currents or GICs. It's naturally electrified by the Earth. A railroad line constructed by humans has very long length conductors. These are the metal rails that run around the railroad's length. These are so long, in fact, that they actually pick up GICs or telluric currents along their length, especially during solar storms. In order to utilize these natural Earth energies, a special system is designed. The natural structures in the Earth, such as rivers, oceans, or large lakes, are viewed as an antenna by making these antennas interface with a diode structure, shown here. The diode structure rectifies the currents flowing naturally through the Earth. Over here we have a regular rectenna from Raytheon. A Raytheon rectenna is designed to take microwave radiation and turn it into direct current. That's the design shown there. This is an extremely low frequency rectenna designed to take Earth energies and do much the same thing. It has as one electrode combination a platinum and gold plated wires. The platinum and gold plated wires here on the first electrode are wrapped around each other in a catechist design, ending in coils around a circular magnet. The other electrode is a regular flat spiral coil electrode, gold plated. This creates a diode effect when immersed in the water or ocean. For more information on these things that have been mentioned, see the homopolar dynamo, Earth geodynamo, geomagnetic induced currents or GICs, Raytheon microwave rectennas in general, tellurics, and extremely low frequency rectennas. Use Google to search for these.